First of all, Jai Hind everyone. Myself, Dr. Kanika, Assistant Professor in Department of Applied Sciences and Humanities in Ajay Kumargar Engineering College. Today, I am going to discuss the Leibniz theorem. So, Leibniz theorem we will use to find the nth derivative of the product of two functions of variable x. So, Leibniz theorem, let if we have two functions u and v, which are the functions of variable x. So we can find the nth derivative of product of these two functions u, v by using Leibniz theorem. According to Leibniz theorem, nth derivative of uv is equals to nth derivative of u into v and plus nc1 n minus 1 times differentiation of u into 1 time differentiation of v and plus nc2 n minus 2 times differentiation of u into 2 times differentiation of v plus up to ncr n minus r times differentiation of u into r times differentiation of v plus u into n times differentiation of v, where ur and vr represents the rth derivative of u and v respectively. And nth derivative of uv we can write in this form un into v plus n, here nc1 is equals to n. So we write this. So and n minus 1 times differentiation of u and 1 time differentiation of v and plus now value of nc2 is equals to n minus 1 upon factorial 2 and n minus 2 times differentiation of v u into 2 times differentiation of v and plus up to ncr n minus r times differentiation of u into r times differentiation of v and plus up to plus u into n times differentiation of v. Now, for example, now we have to find the nth derivative of x square sine 3x. Now here two functions of x square and sine 3x. Now let u is equals to sine 3x and v is equals to x square. Now we have to find the nth derivative of x square and sine 3x, where this is u and this function is v. So we will apply this formula. Nth derivative of u into v is equals to nc0, nth derivative of u into v plus nc1 n minus 1 times differentiation of u into differentiation of v and the plus up to nc and u into nth derivative of v. So now nth derivative, if we find the nth derivative of u, to put here nth derivative of u is equals to nth derivative of sine 3x because u is equals to sine 3x. Now we already know that nth derivative of sine ax plus b is equals to a power n sine n pi by 2 plus ax plus b. Okay, so here we have to put a is equals to 3 and b is equals to 0. So this is equals to 3 power n sine 3x plus n pi by 2. Now the first differentiation of v, dv is equals to differentiation of x square with respect to x is equals to 2x, and now we will again differentiate v with respect to x. So it will be d to v is equals to differentiation of 2x is equals to 2. Now we will again differentiate d to v with respect to x, then here d3v is equals to differentiation of constant term is equals to 0. Now by Leibniz theorem, we already know this formula. So now we will put all these values. NC0 is equals to 1, NC1 is equals to n, NC2 is equals to n minus 1 upon factorial 2, and NCn is equals to 1. Now we will put all these values. Value of u, where u is equal to sine 3x, value of v, which is equal to x square. Now we will put these values, d and u, dn sine 3x and dn minus 1 sine 3x, dx square, dn minus 2 sine 3x. Now we already find this value, 3 power n sine 3x plus n pi by 2 into x square plus value of NC1 is equal to n. Now we know that nth derivative of sine 3x is equal to this, then n minus 1 times differentiation of sine 3x will be is equal to this. Now we will replace n by n minus 1, then we can find the n minus 1 time differentiation of sine 3x. So we get this. Now we have to put this value, differentiation of x square, which is equal to 2x. Now value of NC2 is equal to n minus 1 upon factorial 2 into, now we have to find this value, n minus 2 times differentiation of sine 3x. We know that nth differentiation of sine 3x is equal to this. We will replace n by n minus 2 in this value. So we can find this. Now we have to put the second differentiation of x square, which is equal to 2. So now here we can simplify this. There will be 2nx and simplify this term, and it will be this. So this is the nth derivative of x square sine 3x. Now second example, we have to find the nth derivative of e power x log x. Now again here two functions of x, e power x and log x. Let u is equals to e power x and v is equals to log x. Now nth derivative of u is equals to e power x. We know that if we find the differentiation of e power x, whatever times, it will be equal to e power x. And nth derivative of v, nth derivative of log x is equal to, we already know this, minus 1 power n minus 1 factorial n minus 1 upon x power n. Now we will put these values in this formula, nth derivative of u into v in Leibnitz theorem, and dn e power x, nth derivative of u into v as it is plus nc1, n minus 1 times differentiation of u into 1 time differentiation of v plus nc2, n minus 2 times differentiation of u into 2 times differentiation of v, and plus up to u as it is and n times differentiation of v. Now we will put all these values. Nth derivative of e power x is equal to e power x log x as it is plus nc1, value of nc1 is equal to n. n minus 1 time differentiation of e power x is equal to e power x, and 1 time differentiation of log x is equal to 1 upon x. Now value of nc2 is equal to n minus 1 upon factorial 2 into n minus 2 times differentiation of e power x is equal to e power x, and 2 times differentiation of log x is equal to minus 1 upon x square, and plus up to u as it is, and nth derivative of log x, and derivative of log x is equal to this. Now we put this value Now we can simplify this. Here e power x is common in all terms. So e power x is common and this is remaining term. So this is the nth derivative of e power x log x. Now if y is equal to a cos log x plus b sin log x, then we have to prove that x square y2 plus xy1 plus y is equal to 0. Here y2 is the 2 times differentiation of y, y1 is the 1 time differentiation of y, and we have to prove this relation also. This relation is in yn plus 2, yn plus 1 and in yn. And yn plus 2 is the n plus 2 times differentiation of y, yn plus 1 is the n plus 1 time differentiation of y, yn is the n time differentiation of y. Now this is given, y is equal to this. Now we have to find the y1 because we have to prove this equation. So y1, one time differentiation of y with respect to x. So y1 is equal to a is constant term, positive differentiation of cos log x is equal to sin log x into 1 upon x, and plus constant term as it is, differentiation of sin log x is equal to cos log x into 1 upon x. Or we can take common 1 upon x and do cross multiplication. So x y1 is equal to minus a sin log x plus b cos log x. Now again differentiating this equation with respect to x. So we will find this relation. Now here x y1, we will differentiate x y1 with respect to x. So here let this is first function, this is second function. So this is equals to, we will apply the product rule. First function as it is, differentiation of second function. Differentiation of y1 with respect to x is equals to y2 and plus first function differentiation of x is equals to 1 and second function as it is. So this is equals to x y2 plus y1 is equals to differentiation of sin log x minus a is constant term. So this is as it is, differentiation of sin log x is equals to cos log x into 1 upon x, and plus b, this is constant term, so this is as it is, cos log x, differentiation of cos log x with respect to x is equals to sin log x into 1 upon x. Now we will take common 1 upon x and then cross multiplication. So here will be x square y2 plus x y is equals to minus a cos log x plus b sin log x. Now we know that this term is equals to y. So x square y2 plus x y1 is equals to minus y. So we will take this term in left side. So here will be x square y2 plus x y1 plus y is equals to 0. So we prove this equation. Now we will prove second equation. Second equation is x square yn plus 2 plus 2n minus 1x yn plus 1 plus n square plus 1 yn is equals to 0. Now to prove the second equation, we will differentiate this equation n minus 1 times with respect to x. So differentiation n times differentiation of these equations we'll find by using the Leibnitz theorem. Because if we find the nth derivative of x square y2 and plus nth derivative of xy1 and plus nth derivative of y is equals to nth derivative of 0, which is equals to 0. So we have to apply here Leibniz theorem to find the nth derivative of these functions. Now here two functions x square and y2. Let this is u function, u is equals to x square and v is equals to y2. So put the value of u and v in Leibniz theorem. dn uv is equals to nc0 and the derivative of u into v and plus nc1 and minus 1 time differentiation of u into 1 time differentiation of v and plus so on plus u as it is and nth differentiation of v. So we will put the value of u and v in this formula. So we will get this. Now we take the terms up to this because our u is differentiable only two times. So if we have this term d3 x square, it will be 0, d4 x square is equals to 0, d5 x square is equals to 0. So here will be all terms 0. So we'll take only these up to this term. So plus now another differentiation of x y1, let this function is equals to u and this function is equals to v. Now we will apply this formula again. So u as it is, v as it is, and u another differentiation of v and plus n. Now n plus 1 times differentiation of y1 and and minus 1 time differentiation of y1 and 1 time differentiation of v, which is equals to x. So 1 time differentiation of x is equals to 1 and plus y is equals to 0. Now we will simplify all these terms and then we will get this equation. Now in next example, y is equals to sine m sine inverse x, and we have to prove these two equations. To find the first equation, we will find y1 and then y2, then we will get this equation. Now let y is equal to sine m sine inverse x. Firstly, we will differentiate y with respect to x. So we will get y1 is equals to differentiation of sine m sine inverse x is equals to cos m sine inverse x. Firstly, to find the differentiation of this term, we will consider this term as x, and we know that differentiation of sine x is equals to cos x. So differentiation of this term is equals to cos m sine inverse x. Now we will differentiate this term which I considered as x. So differentiation of m sine inverse x is equals to m upon root 1 minus x square. Now we will take square on both sides. So do cross multiplication. So it will be 1 minus x square y1 square is equals to m square cos square m sine inverse x. Now we know that cos square x is equals to 1 minus sine square x. Now we will apply this formula here. So cos square m sine inverse x is equals to 1 minus sine square m sine inverse x, and this is equals to sine m sine inverse x is equals to y. So the square of this term is equals to y square. Now we find this term. Now we will again differentiate this equation y to find this equation. So again differentiate this equation. It will be 2y1 y2. Now let this is first term, first function, this is second function, So we will apply product rule here, and now here this is constant term, it will be as it is, and differentiation of y square, and differentiation of m square will be 0 because this is constant term. Now differentiation of y1 square. First function as it is 1 minus x square, differentiation of y1 square is equals to, firstly we will treat y1 as x, so it will be 2y1. Now differentiate this term which I considered as x, so differentiation of y1 is equals to y2, so this will be equals to 2y1 y2, and into first function as it is, and minus differentiation of first function minus 2x and second function as it is, and plus 2m square differentiation of y square, differentiation of y square, yes, is equals to, differentiation of y square is equals to 2y y1. Firstly, we will consider y as x, so differentiation of x square is equals to 2x, and now differentiating again with respect to x, so it will be y, and differentiation of m square is equals to 0. So here y1 is common in odd terms, so we will take y1 common, so we will get this equation y2 1 minus x square minus xy1 plus m square y is equals to 0. Now this equation proved. Now we have to prove this equation. So to find this equation, we will differentiate this equation by n times. So differentiate this equation n times by using Leibnitz theorem. Similarly, we will put the nth derivative of uv is equal to this formula, and put the value of u and v here. U is y2 and v is 1 minus x square. So nth derivative of y2 will be equals to yn plus 2 v as it is, and plus nc1 is equals to n, and n minus 1 time differentiation of y2 will be equals to yn minus 1, and 1 time differentiation of 1 minus x square is equals to minus 2x, and plus n minus 1 upon factorial 2. This is the value of nc2, and now 2 time differentiation of 1 minus x square is equals to minus 2, and n minus 2 times differentiation of y2 is equal to yn minus, and now we will find the differentiation of x y1 by using Leibniz theorem, and plus m square yn, and its derivative of y is equal to yn, and constant term n square as it is. Now we will simplify this and get this equation. Similarly, we can do this example, and here if y is equals to x power n log x, then we have to prove this yn value of yn plus 1 and relation between yn and yn minus 1. So we know that y is equals to this x power n log x. Now we will differentiate y with respect to x. Then y1 is equals to n x n minus 1. We will find differentiation by using product rule. This is first function, or this is second function. So first function as it is, x power n as it is, differentiation of log x is equals to 1 upon x. So this is, it will be equals to this x power n upon x, and plus differentiation of x power n and x power n minus 1, and the second function as it is. Now we will take x LCM and do cross product, then it will be equals to x y1 is equals to n x power n log x plus x power n. Now we know that x power n log x is equals to y. So it will be x y1 is equals to n y plus x power n. Now we have to find the value of yn plus 1, and we already find y1. Now we will differentiate y1 n times with respect to x, then we will get yn plus value. So we will differentiate this term n times by using Leibniz theorem. And differentiation of this term n times n is constant term as it is. Differentiation and differentiation of y with respect to x is equals to yn, and another differentiation of x power n is equal to factorial n. So yn plus, according to this, and yn is cancel out yn, and so yn plus 1 is equals to factorial n upon x. So we proved first part. Now to prove the second part, we have to find the relation of in yn and yn minus 1. So we knows that y is equals to this, so any derivative of this, and now if we can write in this form dn minus 1 time differentiation of 1 time differentiation of x power n into log x, and we can write in this form dn minus 1 into y, and we already find the value of y1, so we will put here the value of y1, and now we will operate this operation in both of the terms, and into n minus 1 time differentiation of this term x power n minus 1 into log x, and n minus 1 time differentiation of x power n minus 1. So because this term is equals to yn, now if we replace n by n minus 1, then this term will be equals to yn minus 1, and into n minus 1 time differentiation of x power n minus 1 is equal to factorial n minus 1. So we have to the second part, yn is equals to yn minus 1 plus factorial n minus 1. Now similarly we can find this example, or now these are the book references. Thank you so much.